So we want to find out how many moles is 2.108 times 10 to the 24th helium atoms. And we're going to use our 4 steps for solving molar conversion problems. We're going to identify the relationship. Then we're going to take the given quantity, make it a fraction, putting it over 1. That's setting it up. Then we're going to take that conversion fraction and then multiply it. We're going to set up the conversion fraction to do the actual conversion. And then finally, we're going to multiply the conversion fraction by the given fraction, do the math, and then solve it out. So walking through the steps, the first step is always to identify the relationship. How many moles, so I know we have moles, is 2.108 times 10 to the 24th helium atoms. So I know I have atoms. And is asking how many moles. So I know I want moles. I had to convert from atoms to moles. Well, how do I convert from atoms to moles? I need to know how many atoms are in the mole, right? Well, we know from the lesson that 1 mole has 6.022 times 10 to the 23rd atoms. That is Avogadro's number, which is useful for us to convert between moles and particles. 1 mole equals 6.022 times 10 to the 23rd atoms. If it were molecules, you'd do the same thing. But in this case, we're doing atoms. So that's our first step, identifying that conversion relationship. What now? We're going to take the given quantity and we're going to make it a fraction by putting it over 1. Here's what I mean by that, what's given to us. 2.108 times 10 to the 24th atoms of helium. That is given to us. I'm going to take it, I'm going to make it a fraction by putting it over 1. That way I have a numerator and a denominator, a top and a bottom. And that's useful because now I can say I have atoms on top. And the fact that I have atoms on top is going to tell me how I set up my next step. The next step is set up the conversion fraction using the conversion relationship. So here's what I mean by that. I'm going to set up that conversion fraction, so we're going to multiply by another fraction. Now this fraction, I'm going to use the relationship to set up this fraction. I know that 1 mole, I have 1 mole, and on this side I have 6.022 times 10 to the 23rd on that side, atoms. So I'm going to look at what I have originally in my given. I have atoms on top. Now, in order for the conversion to work, atoms needs to cancel out. The only way that I can get atoms to cancel is if I take this 6.022 times 10 to the 23rd atoms, and if I go ahead and put it down there on the bottom, that way it's going to cancel. 6.022 times 10 to the 23rd atoms helium. That's going to go on the bottom, and the only thing left to do with this mole over here is just to put it up top. So I'm going to say 1 mole of helium on top. And so my atoms of helium, since it's on the top and on the bottom, atoms cancels out. And that's what we want to do. We want to ensure that the given units cancel. So, because the given units cancel, we can now move on to the next step. The next step is to multiply the conversion fraction by the given fraction. So this, all this times all this, you do a step by step. Multiply across the top, then multiply across the bottom. And so what that's going to look like is, let me get some more paper. Here we go. Equals, now I'm going to say 2.108 times 10 to the 24th times 1 mole, that's up top. 2.108 times 10 to the 24th moles helium, that's on top, because any number times 1 is going to be itself, so that number doesn't change. And my moles of helium unit is still there, that didn't cancel, that's up top. Now on the bottom, I have 1 times 6.022 times 10 to the 23rd, which is going to be 10 to the 23rd. Any number times 1 is going to be itself, so I'm not even going to write this right here. Because this times 1 is going to be itself. So I'm going to have 2.108 times 10 to the 24th up top. I'm going to have 6.022 times 10 to the 23rd on the bottom. And the next step here would be finally to solve the problem by dividing. Now, depending on what calculator you use, you may need to use parentheses. You'll have to put parentheses around your scientific notation like that. Yeah, so that's what I'm going to do. I don't have to do it on my phone calculator, but you may have to do it on your calculator to get the right answer. So just to be safe, I'll do it too. Open parentheses, 2.108 times 10 to the 24th, close parentheses, divided by, open parentheses, 6.022 times 10 to the 23rd, close parentheses, and then I get 3.5. So it appears that my final answer is going to be equal to 3.5 moles of helium. So just to recap, I asked how many moles is 2.108 times 10 to the 24th helium atoms. So the first thing I did was I identified the conversion relationship. Okay, well, so I know that 1 mole is equal to 6.022 times 10 to the 23rd atoms. Then I took the given quantity and I made it a fraction by putting it over 1. That's that. And then I set up the conversion fraction using that conversion relationship. That's this right here. And since I saw that atoms was on top over here, I took my atoms from over here and I put it on the bottom so that it will cancel. And then I took my 1 mole over here and I put it up top. So that's what will be left over. And then after that, I just multiplied across. So that 2.108 times 10 to the 24th times 1 equals 2.108 times 10 to the 24th moles of helium. Because this did not cancel, the moles are still there, and that's the unit we're looking for. And then across the bottom, I have 1 times 6.022 times 10 to the 23rd, which is equal to 6.022 times 10 to the 23rd. Notice, this atom's canceled out, so it doesn't go over here because it canceled. It's no longer there. And then when you finally do the math, that divided by that, you get 3.5 moles. Here we go.